Welcome back to the channel. In this video, we'll see about queue data structure. In previous videos, we have discussed about two other data structures, that is array data structure and also stack data structure. In this lecture, we will see about queue data structure. Queue is also one of the type of linear data structure. It also follows the same fashion that is followed by the arrays and your stack. Despite of being a linear data structure, it is also known as a homogeneous data structure because it holds only the elements of same type here. Like if we create an integer, then it will hold only all the integer values. If it is a string, then it will hold all the string values. Next one is it follows the basic terminology that our methodology we call, that is known as your first in first out methodology. Otherwise we can also call it as a last in last out methodology. So better we call it as first in first out methodology. What does this methodology tell us is, for example, if whoever enters the queue first, they should come out of that particular queue first. Generally in day-to-day lives we see these particular queues everywhere. When you go to a movie, then we need to we need to get a form into a queue, right? So similarly, when you want to board a bus, we used to form a queue. And similarly, when you go to a bank to make a payment or to get some amount to the ATM, also there also we may form some queues. In this, what is happening is whoever enter the first to that particular queue, beginning of the queue, they should be offered with the service and they will be coming out of the queue first, right? This is the basic methodology. And this to implement this particular methodology, we used to have two pointers here, whereas in previous cases we have one pointer in your stack, that is your top pointer. So here we do have two pointers, that is front pointer and rear pointer. So why do we have is as we discussed that in stack, both the insertion and deletion are done at the same point, one end, right? Whereas queue we have two openings, right? That is from the front side it is open, and also from the rear side also it is open, right? Two sides it is open here. So that's why we do have two pointers, that is front pointer and a rear pointer, right? So front pointer is used to remove the elements, to dequeue the elements, right? Dequeue the elements from a particular queue, we make use of your front position. Similarly, rear position is used to the insert, enqueue the elements, that is insert the elements into the queue, we make use of this rear position. We come back to the queue types. We have different types of queues, like a linear queue, circular queue, D queue, and your priority queue. Today we will see about your linear queues, and further videos we will be discussing about circular queue and all these particular queues, priority queue and D queue, right? So next point is operations of the queue. Operations of the queue, like all the data structures, they have some operations. Like in stack we discussed about push and pop operations. So here also we have operations to insert the elements and delete the elements. The operation that is used to insert the element into a queue is known as your enqueue operation. To remove the elements, we make use of an operation known as your dequeue operation. Don't get confused with that dequeue, that is a double-ended queue, and this is a operation dequeue, that is DEQ. Okay, we call it as DEQ. This is DQ. That is enqueue and DQ. Hope you are not getting confused with this enqueue, DQ and DEQ. Okay, so similarly we do also have two other operations. There is other operation is empty operation, to check whether the given queue is empty or not. For example, if there are no elements in the queue, then we can say that the queue is in empty state, right? Similarly, we do also have is full. Is full is to verify whether the queue is full or not, right? If all the elements are filled in the queue, then we call it as a this enqueue operation. So let us go and visualize this. So in visualization, what happens here is, if you take a queue will be something like this. Okay, as I told you that it is having two open ends. This is your front end and this is your rear end. Okay, so now you can insert the elements. So from this side you try to insert it. Whenever you insert an element, it will be coming to the front it will be coming. So let us first I will show you the full queue. If it is filled with the elements, let us assume my queue has 3 elements. So this is a full queue. So now you can visualize it. So if you want to insert a new element, you would be inserting from this side. So if you want to remove an element from the queue, existing queue, then you can do it from here, that is from the front side, and this is your rear side. Now if you want to add an element 40, you are going to do it here, right? So at the rear side. If you want to delete the 10, then your queue will be looking like this: 20, 30 and 40. Okay, your front will be at your 20 and your rear will be at your 40. So right, similarly in array we have an index value, in stack also we have an index value. Now this front and rear value, initially these two are set to -1 value. What does this means? If there are no elements, for example, let us assume that I have a queue like this and I don't have any elements in this particular queue. So there are no elements in this queue. So this is the condition: my front value and also my rear value both are -1. This is -1 and my rear value also -1. In this state I can say that my queue is a empty queue. My queue is a empty queue. When front and rear both becomes -1, then my queue is empty. Hope it is clear. This is the first point. So whenever you are going to enqueue operation, as I told you that all the first element, whenever you are going to insert the first value, so then what happens, front value will be incremented from -1 to 0. Okay, initially this is the case. Whenever I insert an element, for example, let us assume that I'm executing a operation, enqueue operation of 10. Initially my front value is where? So it is at -1. Now my front value moving to 0. Okay, -1 plus 1, -1 plus 1 incremented by 1, then is equal to 0. So front value will be coming to 0. The front value will be coming to 0. So where is my rear value? Rear value is, initially it is -1. So later we will be incrementing. As we are incrementing the, as I told you that the values that generally our insert the values will be inserted in the rear position, right? So rear will be incremented first. Rear will also be incremented first. Rear will also become from -1 plus 1, that is equal to 0. So my rear value also becomes to 0. Right, here I am going to insert the value as 10. Okay, let us assume I am going to enqueue another operation, so enqueue of 20. Okay, in this case what happens, front will not be incremented. This will be done only for the first element. For the next time what happens, rear will be incremented by 1. So now rear will become 1. Okay, and then what happens, into that particular position the element will be inserted here. So next time if I call the enqueue operation of 30, so what happens, again rear value will be incremented by 1 and our rear value becomes 2, right? So now your value will be inserted here, rear of 3, like this. So the rear value will be incremented every time when you are going to insert a particular element here. Okay, this is typically not code, we will see the code later. So typically this will be happening in a queue, right? So but you should observe that first element, whenever you are inserting, then front value will be incremented only 1. So now let us assume my queue size is, the size of this queue size is 3. Okay, so here we have a status. For example, if front equal to 0 and also if rear value equal to size -1, what is your size? 3 minus 1, size -1. Okay, so then what happens, your queue is full. So right, already 3 size, right? My size is how much? 3 minus 1, that is equal to 2. This is a 2 elements. Okay, my 2 index value. So my this queue is already full here. So you understand, now you know the status, like when the queue is empty, when the queue is full here. So before going to enqueue, perform the enqueue operation, you need to verify whether like enqueue is means what you are inserting. Before that you have to verify that this queue is full or not. If queue is full, you cannot insert into this, so you have to use this particular case. If this case, then you have to print that queue is full. Otherwise you can go for this insertion operation. Similarly, for example, you want to do a dequeue operation. Okay, dequeue means you have to remove the elements, okay, from this particular queue here. So whenever in this case what you have to take, the queue should have some elements, right, to delete the elements. So in this case there are no elements. When there are no elements, what you are going to delete here? You are going to delete nothing. So for that case, what you have to check, if front equal to rear equal to -1, then you have to tell the user that the queue is already empty, you cannot delete any element here. If this condition fails, then you can come to the dequeue operation. What does dequeue operation will tell us is, whenever a dequeue operation is happen, so first of all you verify the case, and the next case what we are going to do is front value will be incremented by 1. Okay, front value will be incremented by 1. Okay, just you can write the element, that particular element is popped here, so you move this front value. For example, this is my queue here, so now my queue 10 is removed here, so whenever a new queue is formed, so 2 will be here. Okay, right, and 30 will be here. Already your rear is here. Okay, your rear is at your second position, right? So, and also your front value is coming to the first position. Okay, when first element is removed. When you remove the other element, that is second element is also removed. So in this case, what happens, your queue will be something like this. Your rear is already 2, now your front will be incremented, front also will become 2 here. So now the condition is, we come to the reset condition. Okay, so we are coming to the reset condition. So whenever this front value is becoming to this n-1, and also rear is going to become to the n-1 values. Okay, again we have to reset the queues, because we cannot insert further elements or we cannot delete from here, right? So that's why we are going to reset the value again to the front value is equal to rear value equal to -1, that we are going to see. Right, that will be done in the reset operation, so that again the queue will be freshly created like this. In this case, the queue will be created like this. So hope you understood how the basic terminology of a queue works here, right? Let us go back to the code and we'll see what is happening. So here I have taken, say, a simple example. Here we have created a simple queue here. So in this the size is like this is the size, so size value is 3 here, right? So we're designing a class queue, and we're going to create an array where we are storing all the elements, and the size of this one is like size that is equal to 3. This size, you remember whatever the size I told you there. Okay, next we are declaring 2 pointer variables, that is front value and your rear value, right? So now we are going to create a simple constructor. In this constructor, we are initializing front value and rear value to the -1 value, because initially these two are initialized to these values. Now we are discussing about is full. When I can say that is full, so already I told you one case, like when front value is equal to 0. Okay, front value is equal to 0. We'll go to the diagram again. So in the diagram, we already seen that, in this diagram, when the front value, see here, when the front value is 0 and also rear value is equal to size -1. Okay, so what is size value? 3 -1, that is equal to 2, right? When these two conditions are met, we can say that the queue is full, right? Return true value means it is full. Is true, right? Otherwise return the false value. If it is not, then return the false value. Similarly, boolean is empty. When is it is empty? When your front value is equal to -1, then you can automatically say that there are no elements in this, because when front value is equal to 0, there is one element, right? Front value is equal to 0, there is minimum one element, then only it will be incremented to 0, right? In other case, it will be false value, right? Front is equal to -1, then we can say that it is empty. Only in that case only it will be empty. Okay, and return the true value, otherwise you can return the particular false value, right? So now let us go and see the other operations, like your NQ operation. Whenever you want to do NQ operation, what we have to do is we have to take an element, int element. This is the input element, like 10, 20, 30, whatever we give. First we give the 10 value, NQ of 10. Here in diagram I shown you that. So NQ of 10 here. So here we can see NQ of 10 value. Okay, NQ of 20 value, NQ of 30 value. This element is nothing but this 10, 20 and 30 are the elements here, right? So let us come here. First we will check whether the queue is full or not. As I told you that whenever you want to do the NQ, okay, in a full queue you cannot NQ further elements, right? So that is what the thing here. So if it is full, what you can insert? You cannot insert nothing, right? So already it is full. So that's why we'll check this condition as I told you previously. Is full, then system.out.println, we will print the queue is full value. Else, if a front equal to -1 means initially whenever your queue is empty. In this case, what you do, you increase the front value to 0 for the first element. This condition will be executed only for the first element when the front value is equal to -1, first time only, because second time when you enqueue, then front value will be 0. Third time when you enqueue, the front value will be 0. Fourth time when you enqueue, again in this case the value will be 0 only. First time when you enqueue, then front value will be -1, front will be incremented. I mean, we're changing the front value to your 0 value. Okay, so we're not inserting any element here, but just we're increasing the counter front value to 0, and then what we are doing, we are increasing the rear value, rear plus plus. Okay, that is other case. Now we are coming to the next part of the program, that is rear plus plus. Now after rear is initially -1, okay, already rear is -1 here, we are incrementing it to -1 plus 1 as I shown you previously, so it will become the 0 value here. So now what happens, item of rear, what is this item? Item is an array that is holding the elements, right? So here we created an array int items, right? It hold the 3 elements. Okay, so now item of rear, what is the rear value? 0, right? Item of 0 is equal to element. What is the element value? Element value is 10, right? If you go to the typical diagram, in this typical diagram you can see that, so what is the element value? 10 here, right? Item dot rear. Okay, rear value is how much? 0 here. Okay, 0. Item of the, this is let us assume this is item array. Okay, item of 0 is equal to this 10 value will be inserted here. Okay, so next time when I enqueue second time, so next time I'm going to enqueue this, so this operation is executed second time with 20 value. Again this is going to come here and it will check the if is full. Okay, this queue is not full, right? So again it will go to here, is full means it will come here, front is 0. Okay, this condition is true, but rear is equal to size -1, 3 minus 1 is equal to 2. No, my rear value is how much? Already it is 0 only. Okay, it is not it haven't gone for the 2 value, right? So that's why what it will do, it will return it will return the false value in this case. So whenever it returns a false value, so it is queue is not full, though. Then we come to the else part here. Again, if front equal to -1, this condition also fails because already your front value is 0. Okay, so this condition fails here, so we will come to the rear plus plus here. What is there in the rear plus plus? Okay, ordinary rear value is 0, right? So now rear will be incremented by 1, so now it will become rear value equal to 1. Item of rear is equal to, that is item of 1 is equal to item of 1, it will be there, so equal to element, that is equal to 20 value will be stored in this one. So item of rear is what? This one. Item of rear value is 1, so this one value, so 20 value will be stored from here to here. So right, similarly when you execute the third time, this you are going to take the enqueue operation, again enqueue of 30. So enqueue of 30, again it will check the is full condition, again is full method will be executed, that will be failed, again it will be coming here, front equal to -1, no, not this condition is false, so it will come to the rear plus plus, already rear value is 1, it will come to the 2 value. Item of 2 is equal to element. What is the element? Already 30 is the element, so this will be stored here. So the typical diagram will be something like this. Okay, item of 2 is equal to 30 will be stored here. So right, so now rear value is 2 here, so we will be just printing this every time we will print this element is inserted here. So now what I will be doing is I'm going to enqueue another particular element, enqueue of 40. Okay, so enqueue of 40, whenever it is executed, so it is coming to the first function, that is equal to, with 40 element it will be coming to is full. We'll check the is full condition. Front is already 0 and rear is equal to size -1, that is equal to size is 3, 3 minus 1, that is equal to 2. So this condition is satisfied here. So in this case this will return the true value. So whenever it returns the true value, is full is true means it will print that system.out.println queue is full. When this condition is executed, else will not be executed, so it will end out of this particular enqueue operation. As many number of times you try to do this one, in this loop will be fail, I mean this condition will be fail here. Only if condition is true, so it will print the queue is full, queue is full, queue is full. In this way it will be printing. Hope you understand this one, right? Similarly, we will go for the DQ operation. So in DQ operation, this DQ operation will be returning one element, that is your integer element. Because we are storing the integer values, it will return the DQ value, that is element value. That is why we taken as here int here. So let us go and see, initialize a simple element to store that particular value. When it returns something, I need a container, right, to hold that one. So that element we are going to take here, like if is empty. Okay, we are going to execute the is empty method. If it is empty, we'll print the queue is empty, we cannot delete anything from here. Okay, so then we are going to return the -1 value. Okay, so what is this is empty? We will see here. Is empty is nothing but if front equal to -1. In our case, what is your front value here? In this case, if you see, my queue is already, this is my queue. So in this queue already I have elements like 10, I have element like 20, I have an element like 30. So my index value is 0, 1 and 2. My front value is here at 0 and my rear value is at here 2, right? So this is my typical queue. So what is the condition that we are evaluating here? Is empty, front is equal to -1. No, condition itself fails here because front value is 0. So this queue is not empty here, right? So that's why what you can do, you can enqueue any number of dequeue any number of elements from here. So that's why what we will do, we'll go to the quickly to the else part of the program here. Okay, so this is my else part of the program, this is my else part of the program. So now element is equal to item of front. Okay, so we'll go back here, element is equal to what? So element is equal to item of rear. What is your rear value? Sorry, item of front value. Sorry, well, deleting from front, right? So item of front. So what is the front value? Item of front value is 0, right? So it will be item of 0. What is item of 0? That is 10 value. So element will be 10 here. So it will return the 10 value here. So that is what happens. So with this particular case, what happens? Element is equal to item of front will be there. Now if front is greater than or equal to rear, if front is greater than or equal to rear, we have to check this condition because we have to reset the queue. I told you that reset operation is there. What is your front value? The front value is 0. Front value is basically it was 0, right? So it was 0, right? So greater than or equal to rear value is how much? 2 here, right? So front value is 0, greater than or equal to 2, not false, right? So in this case this will not be executed here. Whenever front value is more than, like it is more than or equal to same, it is equal to rear, then it will, this condition will be executed, otherwise this will not be executed. So this is for the reset specifically. Okay, so now again we will come back to the second case. So now my queue is looking something similar like this. So in this case my queue has only two particular elements, that is 20 and 30, and the index value is these two, my rear value is this one, my front value is equal to 1 here. Okay, my front value is 1 here. So you can see here in this case, if it is if this particular reset operation is not working, then we are having a else part here, that is equal to front plus plus. Okay, front will be incremented by 1. So previously the front value is how much? 0. Now front value is incremented to 1 here. So that's condition satisfies. So system.out.println, just we have deleted the element, that 10 is deleted, so return that particular element we are returning. So next what happens, again what I will do is, again I will be calling the DQ operation, DQ operation, just I will call the DQ operation. So that is equal to element is equal to DQ again. So this time what happens, again DQ operation will be done, again it will check the is empty, there is not empty, right? Because whenever your front value is equal to -1, then only the queue is empty. This condition fails here. So we'll come to the else part, right? So else is equal to element is equal to item of front value. What is your front value? So your front value is 1. Item of front value is 1. Item of 1 is equal to 20. This will be copied into the element. Clear? So your 20 value will be written here. So now again I am checking the front value. Front is greater than or equal to rear. Front value is not equal to greater than or equal to rear, because front value is equal to 1 here and the rear value is equal to 2 here. So 1 is not greater than 2. This condition fails here. So else it will come, front value becomes 2 here, right? So now it will print the deleted the element to 20. So return that particular element. That return value will be written there, right? So now let us go and see the third part of this particular case. In this case we have only one particular element. This element is also deleted, this element is also deleted, right? So now I have only this one. Okay, already my front is incremented from this 1 value to 2 value. So my front value is 2 and already my rear value is 2 here. So right, front value is 2 and rear value is also 2 here. So now what happens? So now we come here, is empty. This condition fails here because it is not -1, right? In this case, else we are going to come here, else element is equal to item of front value. So what is the front value? 2. Item of front, item of 2 value is how much? So here in this case, item of 2 value, item of 2 value is 30. So 30 will be copied into element, right? So this one is copied here, means this one is removed here. So after removing this one, what happens? It will check that front is equal to rear. What it is doing? Front is equal to rear. So now what is the front value? Front value is equal to 2 and rear value is also 2. So this condition satisfied here. So in this case what it will do? Front is equal to -1, rear is equal to -1. What it will do? Front value is equal to -1, it will reset. Rear value is equal to -1, it will reset. So means again the queue is created, right? In this case else what will not be executed, and system.out.println, it will print that the element was deleted and return that particular element. Now okay, now what I am doing here is I am going to enqueue another one. Enqueue, again I am calling this enqueue. Whenever I call this particular enqueue operations, so it will go here, it will check that if is empty. Is empty is nothing but again it will come to the is empty function. Is empty function, if front equal to -1, return true value. So already my front is what? Already I have reset it to the -1, right? Already I have reset it to the -1. So this condition will be true here, written true, right? So is empty. So when it comes to this particular enqueue operation, if is empty, this is true, then what I will do? System.out.println, when I cannot delete any elements here, already the queue is empty here. Okay, and we will return the -1 value. So this is how the basic enqueue operation is going to work here. Okay, similarly you can also display the elements from this one. So if you want to display the elements, just you can verify the first, whenever you want to display some elements, there the element should be there. If it is empty, we cannot display any elements, right? That's why we are checking the is empty condition. If is empty is there, then we will discuss that, I mean we will print that a queue is empty, man. This way we are going to print here. Otherwise what we will do, we will come to here, system.out.println, index value we will see, that is equal to a front value will be printed. Okay, so system.out.println, item of that item, one after another these elements will be printed. Item is equal to front value, that is equal to 0, item less than or equal to rear value, that is equal to 2 value, I plus plus, system.out.println, item of 0, item of 1, item of 2 will be printed here. Whenever condition fails to 3, whenever condition comes to 3, 3 less than or equal to 2, the condition fails here, so it will be coming out of this one. So it will print the rear index value, front index value, rear index value will be printed. In between the elements will be printed here. So right, these are the function calls that I showed you. What are the different function calls that I have shown you? Okay. This is the basic working of a linear queue and how the basic queue data structure is. Hope you understand what is a queue and what are the basic operations of a queue here. Okay. So in further lectures we will see, like in upcoming videos we will see about other type of queues, like double-ended queues will be there. Okay, and also we do have like priority queues are there. So we'll see about priority queues, double-ended queues, and also your circular queues. Okay, so hope you understood something from this video. If so, please like the video and share it with your friends. Okay, please consider subscribing to the channel. It would be very helpful for us. Thank you very much.